Once upon a time, there were two men. One brought capital, factories and world-class manufacturing to China. The other tried to shut China out, only to give it a powerful reason to build its own technology. One was Tim Cook, the other was Donald Trump. Cook's capital and Trump's restrictions were never meant to work together, yet both helped shape China's tech rise. And now, that story has reached the global memory chip industry. Korea has seen this Chinese playbook before, but will this game end the same way? Let's dive in. So, on July 27, CXMT went public in Shanghai. Its shares surged 466%, making it the most valuable company listed in mainland China. It looked less like an IPO, but more like a coronation. Patriotic enthusiasm played a role, but beneath the hype was real business. CXMT now controls roughly 7% of the global DRAM market by revenue. In NAND, YMTC, which hasn't IPO'd yet, has already reached 14%. Then came the machine China was never supposed to build. Shut out of ASML's most advanced system, China began producing an immersion DUV machine of its own. It remains slower, less precise, and unproven in mass production. Goldman Sachs estimates that China is now only reaching a level ASML achieved nearly 2 decades ago. The gap remains massive, but China is no longer starting from zero. And now, headline after headline points to the same development. Apple is knocking on CXMT's door. To the rest of the world, this may look like a new story, but to Korea, it feels like a rerun. So let's rewind to 2004. That was the very year Korea overtook Japan to become the world's largest display maker, and it stayed on top for the next 17 years. Then, Beijing turned displays into a national industrial mission. The government backed producers with factories, land, loans, and subsidies. Companies like BOE built bigger fabs, supply surged, price fell, and a brutal price war followed. By 2021, China had overtaken Korea by revenue, and by 2024, it controlled more than half of the global market in display. Korea, yes, of course, moved up to OLED and left LCD behind, but money was not China's only weapon. Technology moves with people, and sometimes it's stolen. Most recently, a former Samsung researcher was sentenced to 7 years in prison for leaking advanced DRAM process technology to CXMT. Industrial espionage? Seriously, they ain't cool, guys. And surprisingly similar patterns appeared in steel, solar, batteries, and petrochemical, where state-backed Chinese scale eroded Korea's competitive edge. A sad story. The detail changed, but the playbook remained familiar. Subsidize, scale, undercut, replace, and export. And now, that playbook had reached memory chips. And here's where our two men return. In his book, Apple in China, journalist Patrick McGee argues that Apple did far more than assemble iPhones in China. Apple sent engineers, installed equipment, and trained suppliers. Those capabilities later served Chinese brands such as Huawei, Xiaomi, Oppo, and Vivo. Apple did not just build iPhones in China, it helped build China's electronic ecosystems. Then came Trump. In 2019, his administration cut Huawei off from American technology. The goal was simple: slow China down. It did, but it also gave Beijing a deadline for technological independence. Apple taught China how to build. Washington told China it had to build alone. Fascinating backstory, but now back to semiconductors. After all, this is still K-Stock what's happening. So can CXMT repeat the same playbook in memory? First, a very quick memory lesson. So NAND stores your file even when the power is off. DRAM is a short-term memory that helps the device work in real time, and HBM stacks multiple DRAM chips together to move the enormous amounts of AI data that the processor needs. But not all the memory is created equal. China has already closed much of the gap in NAND. YMTC has emerged as a serious competitor, even under US restrictions. But now, even NAND is becoming more specialized. Recently, SanDisk highlighted HBF, which stacks NAND's die to deliver the capacity and the bandwidth AI inference needs. SanDisk and SK Hynix are setting the standards together. And advanced DRAM is less forgiving. HBM raises the difficulty once again. CXMT is catching up surprisingly fast in conventional DRAM, but with HBM, you still have to stack them, control the heat, raise the yield, and pass the customer's qualification. CXMT is projected to reach 5th generation HBM, known as HBM3E, around 2027. That is roughly 3 years after the Korean leaders. By then, Samsung and SK Hynix will already be moving on to HBM4E. China's homegrown DUV system also remains unproven in advanced mass production, making high yields harder to achieve. A roadmap tells us when a chip may be built, but it does not tell us how many good chips can be produced. And the game itself is changing.
I don't want to say that there is no cycle, but I want to say that the cycle movement has to change.
As SK Chairman Choi Tae-won put it, memory is no longer a commodity. It's becoming customized. That makes technology and close collaboration with customers more important. So, what about Apple? Apple may be testing CXMT, but testing is not adoption, and adoption is not price war. CXMT's DRAM is not even cheaper, and China already needs almost every chip CXMT can make for their own AI industry. Meanwhile, AI is driving not only prices, but the amount of memory the whole world needs. So even as CXMT expands, the market may still absorb its supply. In other words, P, price is booming, and Q, quantity is growing with it. The playbook looks familiar, but the ending may not be. CXMT remains behind, especially in HBM. But the bigger concern is the state-driven force behind what it may become tomorrow. China's memory ambition should not be overestimated, but they should not be underestimated either. Same playbook, different ending. What do you think? Let me know in the comments. Hit like, subscribe, and stay tuned.